Okay, so let's work out some of the examples. So let's do example number one. Example number one, we are trying to convert number to scientific notation. So let's do problem A, 5,250. Anytime you see 5,250, we understand there is a dot is right here, all the way to the right after zero. First, note that you should notice that this is big number. And for big number, you need to move this decimal between first and second number. So in this case, it's going to be between 5 and 2. And you move it 3 times to the left. This is the new location of this dot. You can say 525 just to include all the numbers. 525. And then you put 10. So we moved it 3 times and we put 3. It's a big number, so it should be 10 to the positive 3, not to the negative 3. Negative 3 actually makes it smaller. When you work on a big number, you should use positive exponent. So we get 5.25 times 10 to the third. Let's do alternative example of B. We take 0.00065. So in this case, we work on a small number. So the number is small. So for the small number, again, notice the point should become between 6 and 5. First, the non-zero number. So we are going to move this dot 1, 2, 3, 4, 4 times, 4 places to the right. So we use 10. Notice it's a small number between 0 and 1. So we will be using negative sign. And we move it 4 times. So we'll be using negative 4. Okay, let's try another one. C. Let's say we got 943. And again, we are trying to convert it to scientific notation. So there is a dot right after 3. So you can say, so again, it should be between 9 and 4. See, this is incorrect. Uh, so in terms of scientific notation, so it should be between 9 and 4. So it's going to be 9.43 times 10. The number is big. So you'll be using positive exponent. And it should be 2 just because we moved it just 2 places. D. Well, let's say it's going to be negative. So we worked on positive numbers. Right now we can try to do some negative numbers. So let's say we got negative 0.00036. So in this case, again, the point should become, the number should remain negative, negative 3 point. So it should be a new point, new dot should be coming between 3 and 6. And we move it 1, 2, 3, 4, 4 times. So we move it by 4 units. Times 10. The number is small, so we're using negative sign, and number is 4. Just because we move it 4 places to the right, and we use negative exponent. So notice it's negative number, negative exponent. That's okay because negative exponent stays the same as it was before, but it's negative 4 because it's just small value. All right, let's go to example 2. Example 2 will involve conversion of scientific notation to a number. Okay, so let's say we are going to take, so I'm going to give you a few examples. Let's say 2 times, actually just to begin with, let's say if you have 10 to the second. There are two ways of doing this problem. Uh, you can just say one way we understand exponent 2 just means that you take 10 and you multiply twice by itself, so you get 100. Alternative method, we understand if you take 1 and multiply by any number, you should get the same number. So for example, if you take 1.0, which is 1, and you multiply by 10 to the second, it should be the same 10 to the second because the idea still doesn't change. 1.0 doesn't really change things. So you take 1.0, 10 to the 2 means we multiply by 10 to the second power, so we make number larger. We move decimal place twice to the right, so it should become 100. And that comes out to be right after last 0. So see, it doesn't matter which method we use, and we still get the same result. When you take 10 to the negative 2, keep in mind that 10 to the negative 2 is the same as division. So 10 to the negative 2. There is probably there are two methods of doing this problem. If you know this rule from algebra, so the rule that we applying is a to the negative n is equal to 1 over an. If you guys remember these rules, that's fine, because you just put 1 on top, you just take it negative, just gives us reciprocal, you put 1 on top, a in denominator, and you bring it to the to the same value, meaning exponent, but with the negative, with the opposite sign. So if this is negative, it actually becomes positive. So this is the same rule we apply. If you're not familiar with this rule, so obviously you take 1 over 100, let's just finish this up, and you get 0.01. Alternative method, you can take 1.0 times 10 to the negative 2. So you're sort of dividing it. So what you do is you take 1.0 and you bring this dot twice to the left. So you put 0 in front, new location for dot, and you put 0. So it should be 0.01, which again works both ways. Let's try another one. See, we got 2 times 10 to the second. So again, we take 2 dot, we multiply 10 to the second, so we move this dot 2 places to the right. Fill in zeros. This is going to be new dot location, so it's going to be 200. This should be relatively easy. Another one is going to be the negative 0.0033 times 1000, or just 10 to the third. So we are going to move this dot three places to the right. 1, 2, 3, and this is where we stop. So we got negative, see, negative remains negative. Negative number times positive number gives us negative number, 3.3. And that's it. We shouldn't really write anything else. E is going to be 2 times 10 to the negative 2. So in this case, we are getting 2 with a dot. Negative 2 means we move this decimal place twice to the left, 1 and 2, and that's where we stop. So it's 0.02. Any number to the 0 power, so this is really important to memorize, that any number to the 0 power gives us 1. So for example, 2 to the 0, 42 to the 0, 1000 to the 0, all of this gives us 1, and you just must memorize. Okay, so right now we can move to example 3. So example 3 will involve the problems of getting a proper scientific notation. How to get proper scientific notation? For example, just like we said before, proper scientific notation should look like number times 10, some kind of exponent, positive or negative, and this should be a non-zero number. This is the only way proper scientific notation looks like. So let me give you a few examples on that one. So let's say we got negative 0.057 times 10 to the negative 2. This is improper scientific notation. The question is, why is it improper? Because notice that it should be, first number should be non-zero, and it comes out to be first number is 0. So we need to figure out a way of fixing it. So for now, this negative number, let's just keep it negative. Now notice that this number contains two parts. This scientific notation contains two parts. We got part 1, which is actual decimal and decimal number, and part 2, which is base and exponent part. So there is this rule of the scales of balancing. For example, since there are two parts, you can, if once you make one part bigger, let's say by a couple of units, you should make another part smaller by the same number of units. Or there is vice versa. If one part is smaller, you make it smaller, then another part you just make it bigger. But you should keep overall sign. So for example, there is a negative sign. This is the negative sign overall that you should keep, and which we do keep. So 0.057, we understand that should be coming between 5 and 7. So this the decimal should be moving 2 places to the right. So actual numbers that we get is 5.7. Notice that right now we just got to compare this and these two numbers. So since we get 5.7, what's happening is this number increased. Once this number increased by 2 units, this number should be decreasing by 2 units. But make sure on a number line, when you decrease it, you go to the left. When you increase it, you go to the right. So to decrease it, it's actually negative 3 and it's negative 4. So we decrease it by 2 units to the left. So new numbers that you're getting is 10 to the negative 4. Make sure not to write down 0 or anything like that. We decrease it in negative terms, so it should become larger number, but in negative sense. Another problem is going to be 0.045 times 10 to the 5th. So again, two parts. We got part 1 and we got part 2. So this is improper for proper scientific notation. That's wrong, because there is a dot should be between 4 and 5. So we move this decimal point 2 points to the right. We definitely increase the number. If this number is getting larger by 2 units, 5 should get smaller by 2 units. So instead of 10 to the 5th, it becomes 10 to the 3rd. And then we stop. Okay, and let's do one more problem. And this is going to be less problem. So let's say it's negative 8544 times 10 to the negative 7. So as of right now, notice there is a dot right after 4. That's not good, because this is not first and second number. It's after fourth, but it should be between 8 and 5. Make sure to keep negative sign. And you use 44, so it should be between first and second number, between 8 and 5, times 10. So let's see. So over here, overall number has been decreased by 3 units. So from 8,544, this is a large number, and 8.5 is a small number. So overall number has been decreased. If this number has been decreased, then this number should be increased. By how many units? By 3 units. So in terms of increasing negative 7 by 3 units, negative 7 plus 3 gives us negative 4. And make sure not to actually write down negative 10, because negative 10, it's actually decreasing number. It makes it larger negative number, but we should keep it as negative 4. So from negative 7 to negative 4, we actually increase number by 3 units. So this was the last problem for this section.